So now in this lecture we are going to discuss about uh, uh, spring. Okay, and we discuss spring about in very detail. Okay, so let's suppose a simple situation. This is okay. This is wall. Okay, and this is ground, and here this is spring. Okay, and this is its natural length. Okay, natural if there is no force on it. Okay, and this is attached to a block. This is attached to a block. Okay guys, attached to a block of. Okay, okay, now guys, when we displaced this block, let's suppose we had displaced this block by amount x. Here we had displaced this block by amount x, okay, we had displaced it by amount x, so it will be it reached somewhere here. Okay, it reached somewhere here, so this is the new position. Okay guys, this is the new position. It is somewhere here. Okay, so this position, this point will also displaced. This point is also displaced. Okay, because this is not distinct. Okay, so this point is somewhere here. Okay, so my string, this point will displace somewhere here. So in this case here, this is the displacement. Okay, this is the displacement. This is the extra increase. What is the length of increase? Length of string is from here. Okay, for initially this is, now this is the length of string. Okay, so what is the increase in length? X. Okay, x is increase in length. X is increase in length. Okay, increase in length. Okay, so guys, in this case, okay, so uh, in this case, if we draw the freeboard diagram of this block, so here on this block, this is the mg and this is the n, and there is no motion along this vertical. Okay, so this block will apply. Okay, on this block there is a force, and this force there, this is a force, and this force is by spring. Okay, on this block. Okay, so look here, look here, this position, this position is equilibrium position. This position is equilibrium. This is the at this is the position in which length of string is natural. This is the position in which length of string is natural. Okay guys, so this spring will exert a force toward this equilibrium position. Okay, spring will exert a force toward this equilibrium. So this is this is the displacement and this is the new position. So what is the equilibrium position? This. So spring will exert a force toward this equilibrium position. Okay, so this is the toward the equilibrium. So this is the about direction. Who had exert this force? Who had? Okay, question is who had exert this force? Question is spring. Who had exert this force? Spring. And so spring has exert a force Fs on this block. Okay, this is the block. On this block, so spring has exert the force Fs on this block. Okay, so block will also apply a force on spring? by Newton third law, it should apply a force on the spring. So okay, so let's draw the free body diagram. Let's draw the free body diagram of spring. This is the spring, this is the spring. So who has applied the force? Who has applied the force on block? Spring has applied. So will block also apply force on the spring? Yes, of course. So this is force on spring by block. This is force on spring by block. Okay. Okay, guys. So if I say spring is massless. Okay. If I say spring is massless. Okay. So net force on spring must be 0. Okay. If spring is massless, if spring is massless, if spring is massless, then net force on spring must be 0. Must be 0. Question is why? Okay. Why? Okay. Find it by yourself. Find it by yourself. A hint is here. Hint m into a. M is 0. Okay. Fnet is equal to m into a. A is equal to a. M is equal to 0. Okay. So think about this. So net force on spring must be 0. So there must be a force. There must be a force along this direction. There must be a force on string along this direction. Okay. To keep this net force 0. So this is the Fs. Okay. This is so question is who had applied this? Who had applied this force? Who had applied this force? Who had applied this? Answer is wall. Okay. Wall. Who has applied this force? Wall. So spring apply force on wall. Of course, spring apply force on wall. Of course, this is wall. So this is the force by spring. Okay, this is the force on wall by spring. Listen. So one thing should be clear to you. This end of string does not displace anyhow, but this also exert a force. Okay. So force. Okay. Here this end of string is not displaced. This end of string is not displaced. This end of string is not displaced. Okay. But this also exert a force. This also exert a force on wall. Okay. So the force by spring is not depend upon whether the displacement, whether displacement of in take place or not, but it depend upon what is the change in length. What is the change in length? Okay. What is the net change in length of spring? If length of string is okay, what is the and how will determine direction? We will determine direction by this method. Okay. We will determine direction by this method. Okay, guys. So these things are important to analyze. Okay. These things are important to analyze. So spring force is okay. Spring is, and this force, this is Fs is equal to Kx. What is x here? Net change in length. net change in length, net change in length. Okay, net change in length of spring, of spring, of spring. Okay, guys, net change in length of spring. Okay, so in there's so many complicated situations arise. Okay, for example, look at this. Uh, let's see some various type of situation in which length of a string is how length of a string is going to change it. Okay, okay, guys. So this is the, let's suppose this is m and this is m. Okay, and here, and let's suppose this moved by amount x somehow. Okay, this moved by amount x1, this moved by amount x from this int moved by amount x. Okay, so okay, so this is okay. So so spring will this end will reach somewhere here, this end reach somewhere here. Okay, this end reach somewhere here, and let's suppose, okay, so and this length is not going to change, so this will be somewhere here. So this length, this position, this length, this position will move, this extend here. Okay, now let's suppose this will move by amount y in this direction. Okay, this will move by amount y. So what is, so this guy will move here, and this will be somewhere here. Okay, so this is the new position, this is the new position, and it this will be somewhere here. Okay, so and this is the y. So this is the new, and what is the, okay, this is the new end. So this end will be this somewhere here. Okay, and this will be, this length will be from here to here, this length is y, this length is y from here to here. Let me draw a big line. From here to here, this length is y. Okay, so what is the new length, what is the new length of a spring? Okay, let's suppose initial length of a spring. Okay, so do it some mathematics, you have to do it. Okay, if or if you're going to memorize my step, then I don't think you will learn. You have to do it, you have to find what is required to solve such type of question. Okay, let's suppose this is the initial length of a string. From here to here, this is the initial length of a string. Okay, we trying to find out what is the new length, what is the new length. Okay, guys, so what is the new position, this is the new position, this is my new position. I have to find this length, I have to find my this length. No, I have to find my this length. What is the this length? Okay, guys, I have to find what is the this length. What is this length? I have to find what is the this length. Okay, guys, so what is I have to find what is this length. Okay, I have to find what is this length. So this length will be, okay, so this, okay, I know from here to here, from here to here is L. So this length and this is y, so this length will be L minus y, this length will be L minus y. Okay, and I know this length is x. So from here to here, this will be, so what is the my new length? L minus y. plus x. Okay, so what is the change in length? Change in length is L minus y minus L minus y minus L. So what is the change in length? X minus y. This is the change in length. Okay, change in length, change in length, change in length. Okay, this is the change in length. So this will be the change in length. Okay, guys. So uh, this will be, so we have to find what is the change in length. So this is the change in length, and now, and if you practice, then this finding of change in length become very simple. Okay, but you have to practice first. During practice it may look slightly weird, but you have to find. So change in length is equal to x minus y, x minus y. This will be change in length. Now let's suppose, okay, so what is the force? What is the force? F is equal to k x minus y. This is force by spring. This is force by spring. Okay. Oh, now if if length of spring is increased, if length of spring is increased, then force on spring will be in this manner. To keep this thing in this manner. This is if length of string is increased. If length of string is increased, then force will be this. Okay, and we will determine by thinking about. Okay, and length of string is going to decrease. If length of string is going to decrease, then force on string by other block will be in this manner. If length of string is decreased, in this manner. Okay, fs. Okay, so we have to check whether length of string is increasing or decreasing. Okay, guys. So so if you think about that equilibrium position, okay, so it will create slightly big problem, okay, in such type of situation. So if length of string is going to increase, then force on spring will be this manner, and if length of spring is going to decrease, then force on spring will be in this manner. Okay, guys. And and with the help of this and Newton third law, we will determine what should be the forces on each block, which is on each end of the masses which are attached with the spring. Okay, guys. So these things are very important to calculate. Okay, you may travel so many situations. Okay, for example, let's suppose uh, let me let me erase it. Let me find a new page. Don't save. Okay, let's see a new situation in which this is like this. This is wall. Okay, this is wall. Okay, this is wall, and here this is wall, or this is block of mass m, and this of block mass m. Okay, we want to check what will happen if we move the spring in this manner, if we give a velocity to this in this manner. Okay, here if this block is start moving in this manner, okay, what will happen? We want to check. So if this will move in this manner, so what will happen, that length of a string is going to increase. The length of this spring will increase, because after some time it will reach here, so spring will be here. Okay, so length of spring is going to increase. Length of spring. Okay, length, this means the forces on spring will be in this manner. This is fs, and this is Fs. Okay, so who has applied this who has applied this force? Who has applied this force? So if you see, so force on this M, force on this M will be in this manner. Okay, and force on this, okay, let me give A and this is B. Force on B of mass M will be in along this. Okay, this means that this this block A will leave this block A will leave this contact, leave this wall. Okay, leave this wall, leave the contact. Okay, and in question like this, that what if here it is the friction, it is if friction is given here, so people can say what should be the velocity, what should be the minimum velocity if we impart, then that block will start moving, that block will leave this ground, then this block will leave the wall. Okay, so there are so many questions possible here. Okay, now, okay, uh, so so spring is important thing. You have to think how. First is you have to think is how to determine magnitude 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 and magnitude of force, first thing, and second is direction of force. You have to determine direction of force. Okay, you have to determine it. So and and uh, okay, so how, what we do to do it, to find it, what we do what we do first we determine what is the change in length. Change in length change. Okay, length change. First we determine length change. Okay, change in length change of spring. Okay, and by this we determine magnitude. Okay, and second thing we determine length of spring. Length of spring increase, then force on spring will be something like this. This is Fs and this is Fs. Okay, if length of spring is going to increase, and the force of masses which are attached to this will be in this manner by Newton law. Okay, Fs here, this is Fs which is attached. Okay, and okay, so by this I determine direction, and if length of string is going to, okay, by this we determine, okay, direction, and here we take the help of Newton's law. Here we take the help of Newton third law. Help of Newton third law. Okay, so this is the way I do. This is the way I determine, and it's depend upon you how you want to determine, but you have to determine whenever you face a spring, you have to find magnitude and direction of force. So by what method I did determine magnitude of force? I determine what is the change in length of the spring. If length of a spring is changes, then there will be force by spring, there will be force on spring, and if length of a spring is increased, then this is the direction of forces on spring, and if I know this direction, then I will determine what should be the forces by spring on their ends. Okay, and if length of spring is going to decrease, so there should be a compressive type of force. Length of spring going to decrease, so forces on spring is something like this. This is the Fs and this is the Fs. Okay, length length of spring decrease, length decrease. Okay guys, length of spring decrease. And and with the help of Newton law here, what we do, this is at this end, this will be the force, okay, and at this end this will be the force, okay, by Newton third law, Newton third law. Okay, so so we take the help, of these things to determine what should be the magnitude and direction of forces by this spring. Okay, okay, so till now, okay, so and if you do these things, then you are able to solve a lot of problem of spring, okay, a lot of problem on spring, okay, and okay, and there are some few problem which will require some a special type of attention, which will discuss, which I will discuss when I solve that problem, okay. Okay, so let's solve the problem on spring. Let's solve. Let's solve. We will solve work energy in later stage. First, let's solve the problem involving the spring. First, solve the problem involving the spring. Okay. 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 So force by spring is F. Force of spring is equal to K into change in length. Change in length. Okay. Q K into change in length of spring. Force. This is force by spring. Okay. So let's solve some problem. Let's solve some problem on spring. Okay. Let's solve some problem on spring. Okay. Let's solve some problem on spring. Here. Okay. So okay. This is in equilibrium position. This is in equilibrium position. Okay. In equilibrium. This is mass mass m. So we have to find what is the spring constant. Okay, spring sorry, spring constant is K. Let's suppose spring constant is K. So we have to find what is the change in length. We have to find what is the change in length. So if I draw the free body diagram, if I draw the free body diagram, so this is the mg and it is in equilibrium. So spring force must be along this. Spring force must be along this. Okay. So spring force must be along this. So let's draw the free body diagram. Let's draw the free body diagram of spring. So this is the F. Okay, and spring is massless, so net force on spring should be 0. So this is the F. Okay, this means that length of spring is going to increase. This means that length of spring length of spring increase. Length of spring increase. Okay, length of spring increase. Okay guys. Okay, and okay, and so what okay, so mg is equal to F. Okay, and what is the F? F is equal to K into change in length. Okay, so what is the change in length? Change in length is equal to mg by K, and length of spring is going to increase by this amount. Okay, If this, okay, if initial length is li, so what is the new length? New length will be li plus mg by k. This will be the new length of the spring. Okay, guys. um, okay, let's solve a new question. Let's solve a new question. Let's solve a new question. uh, this is a spring. This is a spring. Okay, okay, this is m, and this from here is another spring. This is 2m. Okay, and this is k, and this is k by 2. Let's suppose this is k by 2. This is k by 2. So we have to find, and this is in equilibrium. The whole system is in equilibrium. This is spring S1, this is spring S2. Equilibrium, whole system is in equilibrium. So we have to find what is the change in length. Find change in length, of spring group. Okay, of S1 first, and then change in length of S2, then S2. Okay, we have to find what is the change in length of S1, then what is the change in length of S2. Okay, we have to find these two. We have to find these two things. Okay, so let's think about change in length of S1 and S2. Okay, so here, think about the equilibrium here. Here this is this force at. Okay, I'm going to draw the Fibor diagram of this 2m. Okay, first going to draw the Fibor diagram of 2m. So here is the force 2mg. Okay, this is equilibrium, so there must be a force here, f of spring. There must be a force here, f of spring. Okay, guys, so this force, this must be a force here, f of spring. Okay, so, and this is equilibrium, so f is equal to 2mg. Okay, f is equal to 2mg. Now if I draw the Fibor diagram of this S2, let's draw the Fibor diagram of this S2. So okay, this will be the Fs, and since spring is in equilibrium, okay, net force on spring is massless, so net force on spring should be 0, so this will be the Fs. Okay, this means length of spring is going to increase. Length of spring is going to increase. And by how much amount? Okay, so Fs is equal to K into length, increase in length. Okay, so what is the Fs? Fs is equal to 2mg. So 2mg by K, this will be the length, increase in length. Okay, increase in length. Okay, this will be the increase in length. Okay, now we are going to draw the Fibor diagram of this. Okay, question: who had applied this force? Okay, to draw it will necessary to draw the figure diagram of this. So this is the mg, this is the mg, and this is the fs, and this is the fs. Okay, so to keep the there must be a force here. There must be a force here. Okay, so what is the f? If this is in equilibrium, so f is equal to, so f is equal to, okay, this is in equilibrium, so f is equal to uh, 2 mg, because fs is equal to 2 mg plus mg. This must be 3 mg. fs is equal to 3 mg. Okay guys, okay, f is equal to 3 mg. Now we are going to draw the figure diagram for s1. We are going to, this is the s2. Now s2, now we are going to draw the figure diagram for s1. Okay, so okay, so this, who has applied this force? Spring on this mkg block. Okay, so this mkg block also apply a force on spring, so this is the f. Okay, and the spring is massless, so net force on spring should be 0, so this must be f. Okay, this must be f. So f, and the f is equal to k into change in, okay, change in length. Okay, and this, so that length of a spring is going to increase here, length of a spring is going to increase. This shows that, where it is, okay, length of a spring, length of a spring, length of a spring, length of a spring, length of a spring will increase. Okay, length of spring will increase. Okay guys, length of spring will increase. Okay, length of spring will increase. And okay, so f is equal to what is the f? F is equal to 3 mg, and this should be equal to k by 2 into increase in length, increase in length. So what will be this? This will be 6 mg by k. Okay, this should be equal to increase in length. So length of this spring is also increase, and length of this spring is will also increase. But you should note here, here the length of this will increase very high, and length of this will increase slightly small. Okay, length of this spring will increase slightly small. Okay, okay, so these things are very important to analyze. Okay guys, this such type of analysis is important. Okay, let's do another question. Let's do another question. Non spring, let's suppose, let's suppose, okay,